Morning, everybody. Can you hear me around the room? Yeah, okay, I see some thumbs, great. Awesome presentation so far. Thanks, Daniel and Karen. Really enjoying getting the full perspective on what you all are doing. So I hope you guys are enjoying the session. I'm here to talk about EO API. My name is Henry. I come from Development Seed. I'm based in Minnesota, but our office is actually just a couple blocks away from here, up on 9th Street. Okay, so here's Development Seed. We're freezing our tails off in an alley in DC in February. We're a team of engineers and designers, and we build geospatial software out in the open. That is our mission. We have partners all over federal government, NGOs around the world, and we just turned 22 years old on Monday, so happy birthday, DevSeed. I'm here to talk today about EO API, which is our cloud-native geospatial tech stack. Many of you have probably heard the terms cloud-native geospatial. I'll get into some definitions, but the point is, it is available to everybody now, but it's hard to get started. So that's what DevSeed is trying to do with EO API, is provide an easy on-ramp into a cloud-native tech stack. So here's some terms to throw at you. The take-home is really just to make more data more accessible to more people more quickly. That's what cloud-native is. We want rapid access to data as it comes in. We don't want to have, we want to minimize the number of complicated pipelines that a file has to go through before it can land in someone's web browser, someone who needs the information today. We've got a bunch of materials at this is a picture of our zine, the Cloud Native Geospatial zine. If you're interested in some cartoons about this, you can come check that out. Yeah, so those are just a couple definitions for you, Cloud Native Geospatial. So why is it hard to get started with Cloud Native Geospatial? How many in the room are familiar with STAC, SpatioTemporal Asset Catalog? Great, love that. STAC is awesome. It's been gaining a lot of momentum in the last couple of years, becoming the de facto standard for cataloging geospatial assets. The trouble is, it's pretty hard to get started. Before I was at DevSeed, I was at a small company, and I had been familiar with STAC, and I was using STAC in my own workflows, but I wanted to bring it into our own system so that we could use the same tools that were available. But it was really hard to get started. But thankfully, there is EO API, which is an easier to deploy, easy with an asterisk. Nothing is ever quite so simple, but EO API is a set of sensible defaults for someone who wants to, or an organization who wants to get up and running with this technology. You want to have your data cataloged in a stack, a SpatioTemporal Asset Catalog, because it opens up possibilities for a ton of tools that are out there and built on the stack standards. And I'll talk about a couple of those tools coming up. So the four main components of EO API are pgstack, which is a Postgres extension for, that adds stack capability to a Postgres database. And once you have your data cataloged in the stack, in pgstack, then these other tools become, they activate. It's like, oh, there's data in the stack. You can use stack-fastapi-pgstack to serve your data out to other users. And users out there know how to talk to a Stack API. So that's why stack-fastapi-pgstack is good. tiler-pgstack is the visualization platform for viewing data, browsing data. Humans don't necessarily like to crawl through a data catalog in a JSON document in their web browser. They like to be able to look at it. Like, I want to look at satellite imagery, the most recent collections that I can. tiler-pgstack makes that possible. Once the data land in a cloud storage bucket, there's something, a process that would happen that creates the stack metadata for that. If you have tiler-pgstack sitting next to your pgstack database, suddenly you can open the latest imagery in your browser, or anybody can. So that's the visualization platform. And then TPG is the vector side of things. So how to serve data into map clients in vector form. So it's a PostGIS extension that you run next to a Postgres database, and it has an OGC features API and tiles API. So that's the quick rundown on EO API. Yeah, the whole point is it's open. Anyone can use it. You could go home tonight and download it on your laptop and run it and play with it if you want. But you get all these OGC-compliant services. tiler-pgstack is a OGC tile server, and TPG is the vector server, and the STAC API is, yeah, there are a lot of tools out there for working with STAC APIs. So you get a lot for free once your data are cataloged in a stack. All right, I've got some videos to play here. I'll just sort of narrate as we go, but what I want you all to walk home today remembering is that once your data is cataloged in a stack, a lot of things can flow from there without a ton of extra work. So we're looking at STAC Browser right now, which is a tool that can talk to a STAC API and produce this beautiful interface where a user can interact with the items that are cataloged in the STAC database. This is a view of the same data set available in the VETA platform, which is a NASA site, where we've got the same thing we were looking at in STAC Browser, but this is in VETA, and VETA knows how to talk to a STAC API. We'll have another VETA example later. But yeah, that's the STAC advantage, the EO API advantage. I mentioned deployments. Like, you don't have to spend a lot of money to get started working on in this kind of ecosystem. We have deployable repositories out there that you could take home and use today. All right, 2 minutes to go. All right, so I'm going to breeze through the next couple slides. Here's just a demo from VETA. I mentioned that earlier. The theme here is resilience and response. We want the data to be available as soon as possible. So we had some data from the wildfires in Los Angeles in January. And in this example, we can see I think I have wind gusts and some imagery. And when the data are in a stack catalog, tools like this can make it very simple to layer them together. Totally disparate sources, but they can be layered together here. So we've got some imagery and then some wind gusts that are coming up behind it. So 2 totally different sources, I think a NOAA and a Maxar image here, but they're both in stack. The Planetary Computer is built on EO API components. All the visualization is running on tiler-pgstack. I think of this as the gold standard for a stack-based visualization platform. So if you haven't played around with it, definitely go check out the Planetary Computer. It's really awesome. This is just a view of the data catalog interface. It's all backed by a STAC API, and it's got a really beautiful visual interface for looking at imagery. So there it is. The tiles are coming. Yeah, and this is, as soon as the data lands in a storage bucket in Azure, then this becomes possible. They've got a processing workflow that once the data lands, it's available in the browser like this. Okay, next slide. Oop, it's not going to let me go past. There we go. Okay, I had one other demo related to fire events, but in the interest of time, I think I'll just skip to the end here, which is, if you want to start with this, I mentioned earlier you could go home and run it on your laptop. And I'll make sure the links are available to everybody, but yeah, you can run it in a Docker Compose file on your laptop and play around with it. And we've got a workshop tomorrow. If you want to join us in the morning, we've got plenty of space, I think, so come on down to the American Red Cross. Talk to me if you want more info about that. And if you can't make it, all the materials will be available to you, and I'll find a way to distribute that. Yeah, so that's what I've got. Thanks a lot for your time. Appreciate it, and talk to me afterwards if you got any questions.